Okay. In this mid-segment activity, the first question is, what's the midpoint of a line segment? So basically, it's a point that divides a segment into two equal pieces. Those pieces are segments. So a mid-segment of a triangle is a line segment that uses two midpoints. So they ask you in this one to do a visual proof between line segment XY and AC. So we're looking for the midpoint of AB. So AB is 12 units long. So I will put X here. And BC is 8 units long. So I'll put Y, the fourth unit. So that would be the mid-segment of this triangle using AC. And then the mid-segment for the second triangle. We got 6 units on AB, so X would be split into 3 and 3. On BC, also 6 units, and so Y would be split into 3 and 3. So the mid-segment and would be just by connecting the 2 midpoints. It's asking you to kind of look at the visual, what appears to be true about line segment XY as it compares to AC in both cases. And then ask you to use your geometry tools. You can use patty paper, you can use a ruler, you can use protractors with those geometry tools to try to figure out what's happening. And then did your measurements actually support? So is there a relationship between the segments? So hopefully you found a couple of things. If you've not done this, it's probably a good time to turn the video off and do those measurements. If you have completed it, hopefully you notice that XY is half the length of AB, which are AC, in both cases. And hopefully you noticed, using a protractor or pad paper, the line segment XY and line segment AC appear to be parallel to each other. Appear to be parallel. So XY appears to be half of AC, and both segments are parallel to each other. So each triangle, find the midpoint of line segment AC and BC. Label the midpoint of the line segment as X and BC as Y, same thing we just did. Draw in line segment XY, then use your geometry tools to measure those the segments and the angles, and what relationship appears to be true. So after measuring these, hopefully you found the relationship to be consistent. That line segment XY appears to be half of AC, and it appears that line segment XY and AC, they appear to be parallel based on the fact that corresponding angles would be one justification. The triangles are actually similar to each other based on the fact that they do share the same angles, and the ratios between corresponding sides is 2 to 1 because we're using the midpoint on the two sides. Ask you to do the same thing for the next triangle. So hopefully you have done that. If you've not noticed, I'm using the same triangle. I'm just asking you to use a different pair of sides to see if the relationship holds true no matter which pair of sides I choose. So if you've not done this, go ahead and complete this. So after completing the measurement, again, hopefully you found that line segment XY is half of BC. This will be compared to BC. And hopefully you found that XY and BC segments are parallel, because once again, those corresponding angles in both triangles are congruent to each other. Therefore, the segments have to be parallel. I'm going to go back and make a correction here. This is not line segment AC. Hopefully you did AB. Just think about the previous problem, which was ACs, and I wrote down AC again. So hopefully again, it's half of XY is half of AB, and line segments XY and AB are parallel to each other. So in the last problem here, they're asking you for the exercise is what appears to be the relationship between the four triangles. So hopefully, if you have a sheet of pad paper, this would be a perfect opportunity to check that out. But because these segments here are parallel to each other, that makes these angles the same and these angles the same. Same thing here. Hopefully you decided that going through that with padding paper especially, you would find that this angle here would be the same because again, AB and the segment here I'll call XY, they're parallel, which makes those angles the same. Same thing is true here as well. And because again, this segment here, as I'll call XZ, is parallel to BC, that means that the angle at C and the angle here will be the same. Same thing on the other one, if I use the letter Z, that the angle at C and the angle here at X, they're going to be the same. So the triangles end up being similar to each other, the three triangles that are not shaded. And if you go one step further, you would also find that that triangle that is shaded is actually congruent to the other three triangles. They all have, those four small triangles all have the same measurements. So they are, those four small triangles are all congruent to each other and similar to triangle ABC. So they're asking for in the final set of problems is to try to decide what the measurements would be. Since these are the mid-segments, since ZY is the mid-segment and parallel to JL, then ZY is half of JL, so line segment JL would have a length of 18. In problem 2, XW is the mid-segment and it is parallel to GI. Since GI is 22, that means HW will have a length of 11. In problem 3, JL is parallel to mid-segment XY. Since the mid-segment XY is 12, then that means JL has a length of 24. In the fourth problem, we're asking for some angle measurements. Because the mid-segment is parallel to that to the side with the 60 to 40, that means angle X would be 60. And then if I slide the angle up as a corresponding angle, the angle next to the Y is 40 because the angle down here is 40. And since these two angles here create a straight angle, or also called a linear pair of angles, angle Y would be 140 degrees because those two angles have to add up to 180 degrees. So X is 60 and Y is 140. And the last one, we're asking for the perimeter of the small triangle at top. Since this mid-segment is parallel to the side of 20, PO is 10. Since TO and OA are marked equal, TO is 10. And since RP and PT are marked the same, that means TP is 8. So the perimeter of that small triangle will be the sum of the three lengths. So hopefully you determine that answer to be 28. So this is the first of 2 videos. The second video will cover the trapezoid portion of the activity.